Oh, yeah, okay. Well, my 8 minutes starts now, so here goes. Okay, Donncha Maidín is my name. I started working with score representation around the early 1970s, which is a long time ago. At the time, there was actually very good ways of representing a score in a computer. But what was lacking was mature software to process that. My own odyssey through software went via various versions of Fortran, BASIC when PCs became available, which were unthinkable in the 1970s, Pascal, C, and eventually C++. It wasn't until these later programs that there was a facility to represent music in scores in a reasonable way. For that, you're required to be able to represent linked lists, strings, rational numbers, and sets. Additionally, the substantial complexity has to be hidden, and it was the development of object-oriented technologies enabled that to happen. Anyone who's learned the piano at an early age and got to the stage where they can play music from sight has absorbed an awful lot of detail, which has to be imitated in any software that tries to make sense of a score. C++ is object-oriented, so it's good at hiding complexity, it's procedural, and it is available. So this became available around the second half of the 1980s. I converted my work into C++, presented it for a PhD, which was in 1995. I had to give the thing a name because it was used subsequently, so I called it a name that nobody else had called their stuff, CPN View, CPN standing for Common Practice Notation. It represents a score object, it encapsulates that, so the complexity is hidden. And most important, the most complicated object is the iterator. This is a device to get at the internals of a score. And I'll illustrate the principles, first of all, on which the score was represented. I represent only primitives of score objects, such as clefs, key signatures, time signatures, notes, rest, bar lines, with a one-to-one correspondence between the symbol on the printed page and what's in the model. The other thing is to do that in a very objective way, so you don't prejudge anything. For example, a curved line on a score can be a phrase mark, it can be a slur, it can be a bowing instruction if it is for strings. So I just recorded at the basic level that this is a curved line, and maybe at some higher level a decision can be taken on what it is. But this is necessary to completely objectively represent the score. I developed a number of inputs. There was a code available in the 70s for representing score called ALMA, which probably nobody knows. ESAC was Helmut Schafrath's representation, has a lot of German folk songs in it. Kern, which you're probably familiar with, and MusicXML. The Camerata Challenge, of course, brought me into the MusicXML world, and I started getting an ability to import MusicXML. Now I'm going to illustrate how the system works with a demonstration to find the range of pitches in Beethoven Symphony No. 3 exposition, first movement. And a program is created. This is just a shell of a program that does nothing, just sets up the environment for CPN. The first two lines set up the environment, and this is essentially an empty program. The only thing it defines, oops, I go back to there, is the path of where to find the score of Beethoven's Third Symphony. I create a score object, capital S is for the class, and I call that score, giving it a parameter of where to find the score. Okay. Next, I create the score iterator. Now, you can think of the score iterator as a point of attention on the score, or like maybe a finger that you run along the score. And at any point, you can query, what's at this point? Are you a note? If you're a note, what letter note are you? Where are you in the scale of things? The score iterator starts off just before the first object in the score. The score iterator can be moved around the score. So I've moved it here in the first, I call the score iterator finger here. And it's score iterator finger of the score, which in turn is Beethoven's Third Symphony, first movement, exposition. And the first action taken here is to move finger to the first note in the score. Now, what I'm going to show you on the next slide would be the bit that goes in here between finger and return 0, just to fit it on the screen. And if you've done an introductory program course ever, one of the normal first exercises is pick out the largest number in an array or something, and this is very similar to that. So we do that by calling a member function which extracts the chromatic pitch number. So we ask finger, what note are you at? What is this chromatic pitch number? There's quite a lot of complexity underlying that. So I'm going to first of all set the highest and lowest to this, the pitch of the first note, the chromatic pitch number of the first note. The complexity there, it looks very simple, but actually reading, if you sight read a score to find the pitch of a note, well, there may be an accidental on that note. If there isn't, you've got to look back at what key is this piece of music in. But you've also got to look back earlier in the bar to see, has this pitch been changed previously in the bar? And if it has, it inherits that change. It's something that lots of pieces of software don't do. They detect the very first changed pitch, but they don't detect the subsequent ones. So this is a very simple thing. This is a loop that keeps looping as long as there are more notes to be found, and at each note it extracts the pitch, and this resets highest and lowest depending on whether the pitch is the highest pitch or the lowest pitch so far. I was going to run a program, but I'll save myself 30 seconds by not doing it, and I'll just show you the output of this. I print out, except the program has two further things I've added in. I've added in two more score iterators, and they capture what the highest pitch is and what the lowest pitch is, and just dump them out in a fairly unreadable form, which I'll go and explain. But the very first line of the output is here. So we find the score has a range of 65 semitones. It takes quite a lot of figuring out to do that manually. The second thing there is the pitches. It's from a pitch in bar 42. This is the lowest pitch. This thing is stave number 18, which is the lowest stave, which is the double bass, up to the highest stave. I keep accidentally moving this on. The highest stave 0, which is the flute, and that has that note in the 7th octave and 2nd octave. Interestingly enough, which I hadn't anticipated in advance, one note is just before the other, so it's at a climax. It's actually at the end of where the second subject is introduced. There's a kind of climax. So you have this pitch here at position 1/2 note into the bar, followed by this note at the start of the next bar. Okay, I couldn't help. The language side of it, I better keep looking at my time, yeah. Oh gee, 8 minutes is up. Sorry. Very quickly, the language side here is done by parsing it as a tree. So a tree with one clause in that, and if there are many clauses, D's followed by some ABC, there'll be 2 clauses. And each clause is represented in the tree by a template, and the template is compared to the iterator going through the score. I think for future, there's no mention of the word harmony in any of the challenges there, which I think could be explored in future. Definition of terms is a problem. If you read my paper, you'll see I looked at last year's stuff and found that arpeggio, some of the gold standard for arpeggio didn't strike me as being right. So I decided to do a survey of 5 experienced musicians, and I found a wide range of different opinions. The organist had the least. Unfortunately, we had no harpist in it, but their concept of what an arpeggio was quite different. And if you look up a dictionary, you won't get a satisfactory thing you can put in a definition that you can put in an algorithm either. So there's a challenge there, and this is a challenge that we can use Camerata for. As it happens, I spent most of the year doing last year's ones. I developed a program to completely solve all the problems of the previous year. And when this year's challenge came, it was still under development, so I just ran it through. I discovered 2 days later that the finishing bar I had in each the finishing measure was one ahead of where it should be, so a lot of my answers. But I also found the technology is very, oh, 2 minutes, have I?
I gave up.
Yeah.
You don't have.
I just said the technology is very.
Give me a few more minutes because you started early.
What's that?
I took the liberty of giving you a couple more minutes because you started.
Thank you very much. The technology is very unstable at present, and it's no reflection on the Camerata, on Richard's efforts, but quite a few of the answers are missing. Some of the answers are wrong, and that's reflected in the technology most people are using. This, I think, is Music21 from MIT, which produces wrong answers as far as I can see. I don't know, I'm guessing now, I never use it, but I reckon that's part of the problem. Technology, the score representations don't have that one-to-one, and they don't have that objective, because they've been designed with the end use. They're either designed for printing or information retrieval, and they don't start at the very basic, looking at the primitives of what a score is made of. For example, in one of them, a chord is a primitive, but a chord is up here. What's on the score is individual notes. And what is a chord and what isn't a chord isn't a simple question. Okay, that's about it. Thank you very much.